Sweat glands are a good example of the next stage in glandular complexity. They're coiled, simple, tubular glands, but with a differentiated secretory and duct portion. This image is of a section through the fingertip. Thick skin is on the surface, defined by this thick layer of epidermis, covered by a thick layer of keratin. The ducts of the sweat glands are these very thin, dark-stained lines that extend from the epidermis deep down into almost the junction between the connective tissue dermis, this light pink region, and the hypodermis, which is essentially adipose or fatty tissue. At the base of the dermis, they start coiling and then change abruptly to secretory portions. Because the secretory portion and part of the duct are highly coiled, you can easily find clusters of randomly orientated sections of both. It's worthwhile looking at profiles cut at various angles. I'm now going to show you one of these sweat glands at a higher magnification. The ducts are derivatives of the epidermis and retain their stratified character by consisting of a double layer of dark-stained cells, best observed in transverse sections. The secretory cells are larger and paler than the duct cells. Some nuclei of the secretory portion are dark, while others are pale, and the two sorts of nuclei lie at different heights. Since all of the cells touch the basement membrane, the epithelium is pseudo-stratified. Myoepithelial cells can be seen around the periphery of the secretory portions of the sweat glands. Look very carefully. These are true epithelial cells within the basement membrane, but they have long arms of cytoplasm filled with actin and myosin. Therefore, they can contract and squeeze the sweat out of the lumen of the gland. The arms of cytoplasm tend to extend longitudinally along the gland. So in this image, they appear as small eosinophilic or pink-stained dots on the outside of the secretory cells because the secretory portion has been sectioned transversely.